In this devlog, I will go over my process of creating a system where the player has to turn on the power through a fuse box so that other electrical objects can be interacted with. In the last devlog, all the interactions in my environment were automatic. This was fine initially, but I wanted to take my project from an environment showcase to a game prototype. The first step was to create a blueprint interface. You simply need to add a function to it and that's it. You cannot add any functionality in the interface itself. These functions in the blueprint interface can be used by other blueprints to communicate with each other. And to do that, we need to add the blueprint interface to the blueprints that we want to make interactable. So in my case, I wanted my character blueprint to interact with other objects, which is why in the class settings, if you look at the implemented interfaces, there will be an option to add the blueprint interface. Adding the interface to the blueprint gives us access to all the functions that we created in the interface. So to interact with something, it is first necessary to create an action mapping for interactions. So I have created the IA interact input and I have mapped the E key to this input action. So now when the player presses the E key, the interaction input event is fired, and this event basically gets all the overlapping actors with the capsule component. So all the actors that are overlapping with the character's capsule component will be added to a for loop with a break, and if the overlapping actors have the blueprint interface implemented, they will send a message to the interact function of the blueprint interface. The interact event can be added to other blueprints to receive the message that the player character sends whenever it's overlapping with the actors. So once the actor receives a message for the interaction function, the interaction event will fire. I also created an interact prompt widget that is meant to be a simple UI that shows up on the player's viewport whenever they are in range of interacting with an object. I have also binded the color and opacity of the interact image so that I can darken the color whenever the interact input is being pressed by the user. In the graph, you'll see that the binding is simply a function that returns two different values of linear color depending on if the button is pressed or not. So this variable boolean I've created in the interaction prompt, and we will be accessing this through the player character. In the player character, we can create this interaction widget, and I have promoted the widget to a variable to store it so that I can reference it later on. This reference can be used to get the variable from the interaction prompt, the isPressed boolean, and I have set the value to isPressed for a duration of 0.2 seconds and then set it back to isNotPressed, and I am routing this after the player presses the interact button. So when the player interacts with an object, the UI color of the interact prompt is also changed for a short duration to give the player some feedback. Moving on to the interactable objects, first one is the lamp blueprint. I have added these lamps in the scene that will turn on once the fuse is turned on. So there is no functionality given in the event graph. This blueprint simply has two functions, the switch on function and the switch off function. These functions can be called to change the material of the lamp as well as the light intensity. Similar to the lamp blueprint, the elevator blueprint also has a power on and power off function. These functions can be called to change the material for the bulb I have added on the elevator. This bulb indicates if the elevator has power and hence is accessible or not. The elevator blueprint also has a box collision attached to the elevator cart, so that when the player enters this collision area, the on begin overlap collision for the box is fired, and this event sends the interact area entered function a message. And similarly, once the player leaves this box overlap, the interact area exited function receives a message. And as shown previously, these are functions that were created in the blueprint interface, and the overlap, and once the overlapping object receives this message, so in my case the overlapping object is the player character. So once the player character receives the message, the event interact area entered is fired, and this event adds the interact prompt reference that was saved earlier to the viewport. So these functions are used to add the interaction prompt UI to the viewport and remove it when the player exits the interaction area. Also, when the player is in the elevator's box collision and presses the interact key, a message is sent to the interact function in the elevator's blueprint. So once the elevator receives a message for the interact function, the event interact is fired, which executes these sequences. The first sequence is just a sound, a clicking sound that is played on interacting with the switch. The second sequence is the functionality of the elevator. I am simply using a timeline of 5 seconds to change the relative location of the elevator cart, and I'm also using the do once node so that the player cannot interrupt the movement until it has been completed. So the elevator's direction cannot be changed mid-journey. But for the elevator to be functional, it needs the energy boolean to be true. The energy boolean is a variable that I have created in the elevator blueprint, and it will be false by default. So by default, the elevator won't be accessible. This is where the fuse blueprint comes into play. Similar to the elevator, the fuse blueprint also has a box collision that is used to send a interact area entered message and the interact area exit message to the player character so that the interaction prompt can be displayed on the viewport. But the fuse blueprint also has an bigger box collision called the affect area. This affect area box collision is used to communicate with all the other overlapping blueprints that we want to control using the fuse blueprint. I have also made sure to change the collision preset for the affect area so that the player's pawn is ignored. This way the player does not interact with the fuse blueprint while standing into the affect area. The player can only interact with the fuse blueprint while he is standing into this smaller box collision. In the event graph, once the fuse receives the message for the interact function, the event interact will execute this code. First, an audio component will be played to give player an audio feedback of the switch being turned on or off, and I have added an energy variable, a boolean, to the fuse blueprint which will also be off or false by default. So when energy is false by default, when this blueprint receives the interact message, it will be set to true, and if it was true, it will be set to false. We are also getting the actors that are overlapping with the affect area and adding them to an array. The for each loop will execute the following sequence if the actors that are added to the array have the blueprint interface implemented to them. If that is true, a cast will be made to the lamp blueprint. The object will be the array element itself. If the energy in the fuse is true, the switch on function in the lamp will be called, and if the energy is false, the switch off function will be called, which will essentially turn on or off the lamp. The next sequence we are casting to the elevator blueprint, and if you remember, the elevator blueprint has a energy variable in it, but this energy variable is different to the energy variable in the fuse. So we are casting to the blueprint elevator, and we are setting the energy variable that is in the elevator blueprint to the value of the energy variable in the fuse blueprint. So once these values are equated, and if the energy is true, the power on function will be called, and if it's false, the power off function will be called, similar to the lamp. The fuse also has a fuse on and a fuse off function, which can also be called to change the material that is on the bulb for the fuse. So with the third sequence, the fuse on function is called if the energy is true, and the fuse off function is called if the energy is false. As you can tell, the fuse blueprint is the driver for this entire interaction system, and it relies on this energy boolean. I won't go over the other interactable objects like the roof shutter, because it's the same as the elevator, and the door is similar as well. It just uses set relative rotation instead of location. I also did not talk much about the audio, as I had pushed this part until the very end, but it was not as hard as I had imagined it, simply because my implementation of audio was very simple, and I also did not create the audio from scratch. I have been using the Soundly application to get all my audio, and most of my audio in my project is from Soundly. And as someone who has zero knowledge about sound design, I find it very convenient that I can simply select an audio that I like. If I just select it and drag it, I can import it directly in Unreal from the Soundly application. And I really like this function, and I've been using it in this project. So this is the final result with the interaction and the sound. You can download my game for free and try it out from my itch.io page. The link will be in the description. I know it's not really a game, it's more of a small game prototype, but this being my first game in Unreal Engine, I'm happy how it has turned out. Before this, I have always just been sticking to environments, and adding this small bit of interaction to my environment feels very satisfying and makes it more of a game. I will leave links for videos that I found helpful for building these interaction systems down in the description. That's it for now. Thanks for watching.